Genau, und als nächstes darf ich dann Tuana next speaker is Tuana. Ah, there she is, yeah. And the stage is yours for your keynote that we are all very much looking forward on a very current issue, which is large language or like using large language models for generative search.
Thank you. God, don't stand there. Hi. All right. Hello, everyone. Thank you very much for having me here. Yes, I'm going to be talking about Haystack, which is an open source project by my company, and how you might be able to build generative. I've specified it to QA, but actually I can even start off by saying QA is a subset of search, so a lot of what I'm talking about is about search in general. And I'm hoping that not everyone is absolutely tired of the LLM hype, because there's a lot about LLM hype in here. All right, so a bit about myself before I start. My name is Tuana. I've met some of you already. I'm Turkish English, and I work for Deepset, which is originally a company based out of Berlin, but we're quite remote at this point. I have a background in computer science, but I've been doing DevRel in some respect since 2020. And this is Deepset. So everything I'm talking about today is built by all of these lovely people, and we've actually added a few more recently. And everyone's located all around the planet. And what I'm talking about is one particular product we have, which is the open source product, Haystack. Although we have another one, I'm not going to be talking about that today. All right, so the general structure I'm going to be following is going to be first talking about how I view how question answering has evolved or search has evolved in the recent months, and then how you might be able to build generative QA with Haystack. And then if I have some time, I hope I do because it's quite fun, I'll also start looking into further applications of LLMs that I'm sure some of you have been seeing online recently as well. So without further ado, this graph, there's reasons for these pictures, because this is my very eloquent idea of how human evolution has happened in terms of search, NLP, how we interact with language models, or language, human language, with technology. I see it as the first era. I see it as more like the Stone Age. This is rough around the edges, but gets the job done. The next is, I call it the microscope era. This is a lot more scientific. And then we've got Tinkerbell era that happened very recently, which can be amazing, but also very fickle. You kind of don't know what you're going to end up with. And now we're in this, what I call rocket era, because it's kind of difficult to get it going. It's difficult to get it to work, but once you do get it to work, you can have amazing results. So what do I mean by those eras? I see the Stone Age era as keyword matching. A lot of search systems are actually still based on this. It does the job, but what you end up with simply are matches based on your keywords. The next is where we start to move into AI. We start using extractive models, and here you get an exact answer from your set of documents, but it's quite dry. The answer is there. Whether the answer even doesn't exist, this system will give you an answer with a score. And then we had the Tinkerbell era. This happened very recently. And this is where we use generative models. And you'll notice that the right-hand side has gone away, because with these models, you don't need to provide anything to them. They are designed to not extract answers. They are designed to generate answers or even just content, which resulted in this weird time we went through, I find, a couple of months ago, where you can get amazing results, you can get complete what we call hallucinations. It's fickle. And now what I'm going to be talking about mainly today is this, where we combine what we had with our methodologies with extractive models with the generative models themselves, and this requires some setup because you have to do some work to get this thing going. But the end-generated answer can be actually amazing. All right, so what might the keyword matching Stone Age era look like? So this is a very simple example. Let's say we have a set of documents and I say Kardashian sisters. I might get back something like this. Modern keyword matching algorithms can do clever things like, as you can see, I've got sisters here, but it's matched family and siblings as well. Perfect, we've got a response. We've got the best document out of the set of documents we had, but that's it. It's not telling me anything about Kardashian sisters are X, Y, Z. It's just giving me the document. Next up, we have the extractive QA models, and I'm going to often refer to this as readers, because in Haystack we call this component a reader. This is what you use to interact with extractive models. And as you can see, it's got two inputs. It's got query and context. And the type of application you might result with this is, actually, you can scan that QR code and you'll go to that application working on Hugging Face. And imagine you've got a set of documents about Game of Thrones, and you ask the question, who is Arya's father? This is the type of result you'll get. It's just highlighting the answer in the documents you already have, and it's giving you a relevance score. So this works perfectly, and if the answer didn't exist in your documents, it would still highlight something for you. It would just have a low score. Whatever you do, this system will give you an answer, but it's not telling you about the answer. It's very dry. This is the answer I've got in this piece of text. It's Eddard. And then we move on to the Tinkerbell era. And as you can see, you don't necessarily need the context here at all. You just ask the query. And now the results are completely dependent in this scenario on what your generative model was trained on, what's its general world knowledge. So if I ask the same question to, I'm sure everyone's seen this UI by now, this is ChatGPT, I ask the same question, who's the father of Arya Stark, I don't just get a bland Eddard extracted from somewhere, I get a pretty eloquent, long description of the father of Arya Stark from Game of Thrones. And then what else you can do, and I'm going to come back to this particular ability of these generative models a few more times, is you can also do not just a query. And this is where we start going into the realm of retrieval augmentation, which is what we're going to be talking about today. But as you can see here, I've not just got the query. Technically, the query could be the instruction. I've got an instruction, summarize the following text for me, and I've actually provided some context. Remember, you don't have to provide context, but here I have. And it's done a pretty good job of summarizing this. I just copied over a paragraph about George Washington. But this is important because you can now sort of start to see that some large language models are able to follow a very specific instruction. And this is where you start to hear about the whole thing around prompt engineering, which I'm sure some of you have heard of. This is the whole practice of tweaking that first instruction you give, followed possibly by some context or your own documents, for example, and then telling the large language model exactly what you want it to do with that context and how. All right, so quickly about Haystack, because from now on I'm going to be showing how we might do retrieval augmented QA with Haystack. Haystack is fully open source, it's all written in Python, and the idea behind Haystack is that it covers all core NLP tasks, and the most classic application that you build with Haystack is built on this idea of pipelines. And a classic pipeline might look a bit like this image here. The left-hand side I'm not covering at all today, but that's actually a big chunk of what you might have to do to actually get an application running. And this is all about, I've got all these documents and text data, but language models can be very precise in the shape they need to see those documents so that they can actually work with them. So the left-hand side deals with everything around preparing your data, indexing it into a database that you as a developer have chosen to use. That might be a vector search engine or whatever. And then the right-hand side is what we're going to be looking at, is where you might design your own NLP application pipeline. So this one, I can actually go over here. This one, for example, is a classic one where you might have a retriever, which is a component that is actually really important because it's like a filter between all of your thousands and thousands of documents and the model you want to use. And a retriever acts as a thing where you can ask the query, and it will only get, let's say, the top 3 most relevant documents out of your database. So then the last model doesn't have to deal with thousands, it only has to deal with 3. And then the idea is you decide what kind of pipeline you build, what kind of database you use, whether you have a generator at the end or a reader at the end. So very shortly, this is the idea behind Haystack. And what we're going to be doing is, so I briefly mentioned how a classic extractive QA pipeline has this retriever. And that's what you see on the left-hand side. So the idea is we have a set of documents somewhere, could be thousands. We have a retriever, which is filtering those documents based on your query. And then you have a reader, which is extracting the answer. What we're going to be doing with large language models is we want to do QA, but we want to do it accurately. We want it to work on our data. We're going to apply the same exact logic by using a retriever component and only then following it up by a generator. So how does that work with Haystack? The generator section of this pipeline is largely possible because of 2 components we have. One is called the prompt template, and I hope you remember the word prompt. That's the instruction we're sending to an LLM. And this is sort of like a blueprint of how you, as a developer, design your interaction with the large language model you choose to use. And then the second is boring, in my opinion, the prompt node. This is the one that's actually doing the interaction with the LLM. This is the one sending the prompt, or the query and the prompt, and then receiving the response. And here you have a choice. You as a company might want to use OpenAI, or you might not be comfortable with that, so you can decide to use an open source one from Hugging Face. And actually, by the end of this week, we can also add SageMaker into the mix here. So this is where you get to make some choices, depending on your requirements. All right, so what we're going to be hopefully doing is, and here I'm going to show you an example, so we're doing this, we're building this. So we've got a set of documents, we've got our generative model, and hopefully we end up with good results. So an example of an application that works exactly with this idea in mind is something I built recently, which is quite funny. But imagine the documents are tweet streams, and the query is a username. And everything in the middle is built with Haystack. This is a pipeline that I built with Haystack. And the resulting answer is a tweet analysis. So this is an application I built to basically judge people on Twitter. And it looks a bit like this. And that QR code takes you to that application that's running. You do have to enter an OpenAI key for this, but the idea is the following. So I used my own username, Tuana Çelik, and I say search tweets. And this particular model might not know anything about my tweets so far, but what I'm doing is I'm providing it my tweets, and I've also given it a very specific instruction around what to do with my tweets. And this has resulted in something like this user has lately been tweeting about Haystack, NLP, Eurovision, all accurate, English and Turkish, all accurate. Another funny one, because I'm going to come back to this hopefully at the end, because I'm going to use it as another example for another LLM application. If you haven't seen this Twitter account, I found out about it a few days ago, and it's hilarious. It's called Dog Feelings, and it says this user's been tweeting a lot about their experiences as a pet. They tend to tweet about being a good pet, etc., etc. All right, so what about I have my actual data somewhere? How does this actually even look? How does my interaction with an LLM look? This is another example. So here, this is a public data set. I crawled the PyCon US. So PyCon, I'm sure some of you know about it, is an annual conference that a lot of cities hold it. It's all about Python. And I had a talk at PyCon, and this is The website crawled, and as you can see there, there's talks, tutorials, charlas. These are all the events, etc. at PyCon. So I'm imagining that I am going to be building an application that is able to answer questions specifically about PyCon US. So what might my interaction with an LLM look like? And this is exactly what a prompt template is in Haystack. I've built an instruction. You will be provided a list of events, reply to the query based on the content of the provided events. And then the magic is happening in the things that are highlighted in blue here. They're in curly brackets, and what's important about this is these are manipulated at query time. So I've said query, curly brackets, query, and then events, join documents. And this is important, the join documents part, because this is filled in by the retriever. If I build this into a pipeline, the documents come from the retriever. I've decided to use a function called join, so it's joining all the top, let's say, 3 documents I get. And at query time, what might that look like? It might look a bit like this. So this, in the end, is what I'm sending to whatever LLM I decide to use. The query part is filled in, let's say, with a talk. What day is the talk about agents and LLMs? And then you'll see the retriever has joined contents of various documents that is found to be most relevant from all of these, which is hundreds of lines. And this is an actual copy from a prompt that I tried. I was pretty happy to see that it actually did a pretty good job of extracting the most relevant talks. And then, for example, this is another question I asked, and this is, I'm going to tell you what model I used for this. This was GPT-4 that I used, and I was actually very pleased with the results because no other model that I'd used with this exact setup had done this sort of listing. I said, I'm interested in NLP. What talks should I see? And then it actually kind of made me a program. I've got one, and I also added the URLs of each talk into the content, which meant that not only am I getting a program, but I'm also getting the URL for that particular talk, and I can go check what's going on. And if you want to see what other ways we at DeepSet have been interacting with LLMs, you can actually have a look at Prompt Hub. And maybe I can even show you here, hopefully if it's working. So for example, this is a prompt called question answering with references. So this is instructing a model not only to answer the question, but also it's giving it formatting instructions too, telling it reference the documents that this answer was generated from. Or you can go do others. There's language detection, sentiment analysis, etc. So it's not all about question answering. All right, so everything that we've been talking about so far has been built on this idea of pipelines. So this is where I want to briefly discuss another application that we've become aware of, and now we see it's actually working quite well. And a pipeline, data flows from one node to the next, to the next, to the next. And you as a developer, you're defining what that path is going to be. And the other most important thing is the knowledge base is set. So in my application, if I tell it tweets, the knowledge base is tweets, and plus maybe the general knowledge of that model. If the knowledge base is PyCon data, that's PyCon data. Okay, what if I were to ask this query? So has anyone heard about this Elon versus Zuckerberg fight thing going on? Apparently they're going to have a cage fight. But to my knowledge, no model has been trained since that news came out. So what if I ask, if the Twitter user Dog Feelings were to write a tweet in their style about the Elon v. Zuckerberg fight, what would it be? In an ideal world, you have this sort of structure where you have the query and you're inputting the tweets. And this is what I built yesterday exactly, actually, and it worked pretty well. In an ideal world, you have this. You've got that question and you've got the tweet streams. But the problem, none of the language models know about this new cage fight scenario. Cue in agents, and this I'm sure a lot of you have been hearing about it, but Agents are basically a clever way we prompt an LLM, and it might look a bit like this. This is a very oversimplified view of what an agent actually is in essence. And the idea is you basically tell an LLM, and here I've just made it up, I've just completely made up a scenario, that it has access to tools, and we give names to these tools. And here I've said you've got a tool called Twitter Voice, which is basically using that pipeline I built before, where it's giving a summary of a username's tweets. And then I say web search, and I say this is useful for when you need to research the latest about a new topic. And then the prompt to the instruction to the LLM is pick which tools you'd use to resolve this query, and then we input our query. And then you might end up with something like this. Here you can see even ChatGPT in a made-up scenario was able to give me a pretty good rundown of what it would use and when. But the idea with an agent is that you actually build these tools and you provide it. And this is very different to the pipeline, because where a pipeline was me defining the path that we're taking, node by node, here it's kind of crazy because we're actually giving that job to the LLM. We're telling it, you decide which node or pipeline or tool or knowledge set you access and use based on the inputted query. And that might look a bit like this. I might have an extractive QA pipeline with knowledge base with Game of Thrones as one tool. I might have web search as another tool. I might have a generative pipeline that has access to my PyCon data as another tool. And so I built this, and I gave it 2 tools, and I actually provided web search as a tool and Twitter Voice as another tool, and I asked it the question, what would Dog Feelings tweet be about the Elon v. Zuckerberg fight? And this is very, very small print, so I'll read it. But the answer was, oh heck, the human told me Elon and Zuckerberg are gonna have a cage fight. I hope they bring some squeaky toys, etc., etc. This was actually pretty good, but I built something very similar for PyCon, for example. I actually built this PyCon attendee assistant thing, and I gave it 3 tools. I gave it PyCon event search, speaker search to search about specific speakers, and web search. And this is a video, but if I speed it up, maybe I can bring it up to, no, I can't. And I asked, when is Tuana's talk at PyCon, and what will the weather in Salt Lake City be like that day? First, it did speaker search to find my talk. Oh, okay. And then it did web search to find out what the weather in Salt Lake City was going to be like that day. And unfortunately, it was terrible weather. And it gave me, it's going to be 10 degrees, maybe even snowy someday. I thought it was lying, and then the day came along, and it was actually terrible weather. And this is the latest type of applications we're seeing with LLMs. I find it very interesting and fun. There are some hurdles you have to get through to make this actually work pretty consistently every time. But it is a really magic way of tricking or sort of leveraging the ability of LLMs. That means that they can consume very specific instructions and act on them. All right, and with that I end it, and here are 2 QR codes. One of them takes you to the Haystack tutorials, where you'll find tutorials that do exactly these things I've been talking about, and the other is, I find to be a very relevant webinar, which is all about prompting LLMs with Haystack. Thank you very much.